except for the inception craziness going on. All right, we'll give this a try, see how it goes. So 7th and 8th grade, you're each working on your warm-ups. Does anybody need me to show them how to get back to the warm-up? You guys all remember? Go to the menu under Dynamic Classroom. Well, you guys don't have Dynamic Classroom, that's me. All right, and I'm going to go check and see how we're doing. Interesting. Okay, good. You're already trying it. So there's only one warm-up, 7th grade. Make sure you know the area of a parallelogram. Area of a parallelogram is what? Anybody help?
Is it 1.3 practice?
Yes. Well, you're doing not practice, you're doing the warm-up.
Yeah.
How do you find the area of a parallelogram, 7th grade? No. You just do length times width. It's just a square tilted. So the only difference is, listen, the tilted edge, if there was a measurement on the tilted edge, you don't use that. You use the height of the parallelogram times the base. So you should just be doing 13 times 13. Once you have done that, go to key idea and start writing your key idea. Is there something I'm missing? Big ideas? So close that and open it again. Do it again. All right, 8th grade, I'm going to check your warm-up. All right, 1 second. So 8th grade, your warm-up, you're finding the volume of a prism, which is just length times width times height. Comprende? Good, you got this. All right. Yeah, it worked. Okay, so 8th grade, once you have done your warm-up, please go next and write the key idea as well. Yes. Seventh grade, we're talking about adding rational numbers. So please write that in your journals. Seventh grade, you all have it written?
Yeah.
Okay, so let's go through your example. You wrote the key idea? On your screen. Anytime there's a key idea, it's got red heading, red letters, write it in your journals. It's what you need to take notes on. Okay? If you haven't written it, just leave a space and go back and do it. So the first thing we're going to do is we are adding rational numbers, yes? Okay? What do you notice first when you look at these two fractions? One's negative, absolutely. So even though this is a negative 8 over 3 plus 5 over 6, we're kind of probably going to flip it and do some subtraction, right? But let's look at this. You don't have to do the estimation. So because the signs are different, if I were to look at these as an absolute value type, you would see that the 8/3 is actually going to be greater than the 5/6. So if you found the absolute value of each of those, basically you're switching it around to where you're going to subtract 8/3 minus 5/6. Okay, now whenever you're adding or subtracting fractions, why is there so much giggling going on? Are you paying attention? Writing notes? Journal's not even open. When you're adding or subtracting fractions, what do you have to get first? 7th grade? You can't add or subtract fractions without doing one step first. Nope. You got to get a common denominator. So see here, the 6's. So they took this 8/3 and multiplied the bottom number times what to give me a 6? 3 times 2. So then whatever you do to the bottom number, you do the same to the top number. So if I did 3 times 2 to get 6 on the bottom, what is 8 times 2? 16. So you see how we have 16 now. So now we're going to do 16 over 6 minus 5/3. What is 16 minus 5? 11, and then you just leave the 6. The denominator doesn't subtract, you just leave it there. So 11 over 6, or 1 and 5/6. Now because the 8/3 was larger, your answer is negative. Make sense? Okay, now I want to show you, this was a little more convoluted than I like, so let me move my face. I got an app. Where's my app? Okay. So negative 8/3 plus 5/6. See how terrible I write with a mouse. So negative 8/3 plus 5/6. I'm just doing this again because I want to show you how you don't have to do the absolute value portion of that. Okay, so this is a shorter way to do it. Okay, we already discussed that we have to get a common denominator, so we still need to change this, right? 7th grade, I need you to respond. I don't want to talk to myself the whole night. Morning. Thank you. I appreciate it, but I need 7th grade right now. So we're going to multiply this whole equation times 2, so that way they have the same denominator. So we already know that 8 times 2 is 16, and then 3 times 2 gives me 6. So then I just rewrite this 5 over 6. Okay, now earlier they did all kinds of absolute values and stuff and moved stuff around, right? Yes. You don't have to do that. You can just look at this and go, okay, if I have a negative 16 plus 5, what's my top number going to be? 11. Yes. So you can just look at that and go, negative 16 plus a positive 5 still gives me 11 over 6. You're going to get the same answer either way. And this was a lot faster, right? Yes. Okay, so you're welcome to do it this way. Questions? No. All right. Okay, you may begin your try at 7th grade, 1 through 3, and then stop at example 2 and wait. 8th grade, example 1, are we ready? Yes, ma'am. Yes. Write this in your journals. So we're going to solve 15 minus 2x equals negative 7x. Write that down. 15 minus 2x. You always start by writing the equation. What is the first thing I need to do in order to solve for x? Yes, Samuel?
Divide by 2 on both sides.
It's not divide, Daisy. We're going to add it because this is a minus 2x. So the first thing we're doing is combining like terms. That's the phrase I'd love y'all to say. Combining like terms. This stuff with the x has to be combined with the other stuff with the x. So we're going to add 2x to both sides. What is negative 7x plus 2x going to be? Josh?
Negative 5x.
Negative 5, because it's a bigger number. The negative is larger or whatever. So then you just rewrite 15 equals negative 5x. Now I need to get the x completely by itself. Since this is next to it, it means what? Shout it out.
We're going to divide.
No, what is this? It means multiply, yes. So in order to solve it, Aaron, we're going to divide by negative 5. So what is 15 divided by negative 5, Daisy? Negative 3, very good. So x equals negative 3. You can always check it by plugging a negative 3 right here where this original x is. You see how they plugged it in? Solve it, and does it equal 21? Does equal 21. Not required, but if you always want to check your work, that's how you do it. Any questions? All right, go do your try-its. You only have 2 to start with. And then wait for me at example 2. Okay, so when you're adding a mixed number, can you tell me what that number was? It was negative 1 and 3/8. Plus what? 3/4. Okay, so when you're adding and subtracting fractions, see that we're adding here? Remember, you have to get a common denominator. So we have to make this denominator an 8, right? We also have to make this mixed number improper. Please whisper if you're helping. It's fine, just whisper. So to make this improper, I'm going to multiply 8 times 1 plus 3. 11. So you have 11. Where's my marker? It left me. So this becomes, why is this not working? 11 over 8. All we did was change the mixed number to an improper fraction. Keep the negative. And then now we need to change this fraction to have a common denominator. So what times 4 will give me 8? So we're going to multiply both top and bottom by 2. What is 3 times 2?
6.
So this is 6. And then the bottom number is 8. So when you're adding and subtracting, the denominator does not change. So I could go ahead and write it over there. So now I have a negative 11 plus 6. What's negative 11 plus 6?
Negative 17.
Nope. This is a negative. This is a positive. What? Negative 5 over 8. So it's like the 11 minus 6 and throw the negative back in front of it. Okay? Any questions on how to do that? Yes? You do add them, but you got to remember that this is negative. So if I were to draw a number line, why is this not cooperating with me? I'm way over here right now at negative 11. And then I'm going to add 5. So I go 5 this direction. I'm adding how many? 6. So I'm adding 6. So even though I'm adding 6, I'm still in the negative range, and I only end up at negative 5. So yeah, it's technically adding, but I never get past the 0 on the number line, so I'm still in the negatives. So that's why your answer is a negative 5. And you can always check your work on a calculator, guys. So after you've done it, plug it in the calculator, see if you got it right. Yes, I'll be right there. 8th grade, here's the example 2. This one looks tricky, but just follow the steps and we'll be fine, okay?
Yes, ma'am.
So, the first thing you're going to want to do here is what? Yes, the magic word distributive property. So we're going to distribute this negative 2 and distribute the 6. So, click, click. Why is my screen? There we go. Write the equation first in your journals.
Yes, ma'am.
I have to sneeze, but it's not happening. What is negative 2 times x?
Negative 2x.
Negative 2x. Very good. What is negative 2 times negative 5?
10.
Plus 10.
Plus 10.
Plus 10.
So I should have negative 2x, because a negative times a negative is a positive. Okay, now let's do the right side. What is 6 times 2?
12.
And then what is 6 times a negative 0.5?
Negative 3x.
Negative 3x. Very good. Yeah, don't forget the x. I forgot. I didn't say it. All right, so now that we've simplified and done our distributive property, what is our next step? There's a phrase I really want y'all to learn. Elena? What's the phrase?
Combine like terms.
Camila got it. Max got it. Combine like terms. So what is a like term? The x's. So let's move the x's. Let's take this negative 3x over here. How would I do that, Josh?
Wait, I was just asking, but how do you know which x number to take?
It doesn't matter. You can move it to the left or you can move it to the right. Here's why I'm choosing to move this one. It's going to make it a positive answer because I don't like to deal with negatives, so I don't have to.
You're not a negative person.
I'm not a negative person. I'm a positive person. Thanks. All right, so plus 3x moves it over to the left, and you get what, Elena? What is negative 2x plus 3x? Help her out, Camila. X. Okay, then we just rewrite plus 10 equals 12. Now we need to move the 10 away from the x. Josh?
You subtract 10 on both sides.
We're going to subtract 10 from both sides.
And
So
you get
x equals? Very good. You're so happy. Okay, any questions on how we did this?
No.
So you will have no you'll have no questions on your try-its.
Yeah, Kerwin.
Okay, go do your next try-its. I'll leave this up for just a second. I think somebody's still copying. Okay, that's fine. You have your book. Shh. If you're working, you keep not working. I need you to do your work. Okay, I'm going to close this. And 7th grade, let's go do your example. Okay, 7th grade, write this in your journals. Even if you're not done with your try-its, just skip down in your journal, and here we go. You ready?
No. Yeah.
I heard a no. I'll wait a second. Did he switch it to a yes?
Yes.
All right, so we're going to solve negative 0.75 plus negative 1.5. Okay? First thing you do is write it down. Oh, they're doing it the yucky way.
That's
Yeah.
the way that I do it.
Congratulations. We're going to do it Mrs. Cease's way. Okay, would you read... I need to change this. Pencil's too giant. Okay, somebody read it to me.
0.75 plus
Plus.
1.5.
I didn't hear any negatives.
Negative 1.5.
Negative 0.75 plus negative 1.5.
Very good.
In a parentheses.
This takes forever. I'm going to have to find a way to speed this up. Okay. Negative 0.75 plus negative 1.5. I'm going to show you a little trick. Ugh, why does this do this every time? If you have a marker that works. Come here. Where are you? Why does it do this? I don't understand. This was working just fine. Oh, now it works. Okay, if you have a negative next to a positive like this,
Yes.
the negative wins.
Yay. I mean,
So, well, it is what it is. The negative wins. So don't get confused by this. I would rewrite it. So I'd say negative 0.5. And instead of saying plus a negative, just say minus 1.5. Your kid's crashing into the wall behind me.
yeah, that's my kids.
It's your kids.
Thanks.
Shh. Okay, so if I have negative 0.75 minus 1.5, am I going further negative?
Yeah.
Yes. So if I know I'm going to go further negative, it's like saying add these two and throw a negative in front of it. So what's 1.5 plus 0.75?
It's 1.8.
No. You may use your calculators. Okay, so if I say 1.5 plus 0.75,
Negative
you line the decimals up.
2.25.
What is 7 plus 5?
1 point,
What is 7 plus 5?
12.
Wow.
13.
Get him out of here.
It's 12.
I was right.
Carry the 1. Yes, you were right, Joaquin.
Negative 2.25.
Negative 2.25. Okay, so they were both negative, so we added them and put a negative in front of it for your brains.
Yes.
Okay, you may check it using your calculator. Put that in. Yeah. They do it all complicated. You can do it this way. You find the absolute values, add them, and then put a negative in front.
Yeah, that's what I did.
It's fine. That's fine too. That works for your brain. There is a lot of times more than one way to solve a problem. I don't have a problem with you doing it the way your brain sees it. Okay? I'm happy to help explain it more than one way. All right, do your next set, 7th grade. Try it 4 through 6 and self-assessment through number 11. So go all the way to number 11 before you stop. 8th grade, are you supposed to be doing self-assess? Oh, no, we have an example. That's fine. I'm just making sure. All right, I will wait for you. Okay, real quick. 8th grade, I'm going to start with you. I know you're not done with your try-its. That's fine. Just go grab your journal, and we're going to go ahead and do the last example real quick.
Yes, ma'am.
So 8th grade, journal, example 3. Okay, remember this assignment's not due till tomorrow, so you have the rest of today to turn in the try-its and self-assessments. Yeah, you work tonight. All right, here we go. We're solving 3 minus 4x equals negative 7 minus 4x. So first thing you do is write it down in your journal. Okay, what is the first step to this? Yay! Combine like terms. So let's move one of these negative 4x's. Which one do we want to move?
The first one.
Doesn't really matter, but yes, let's move the first one. What does a negative 4x plus 4x equal?
0.
So nothing. So it cancels. It's gone.
Yeah, bye-bye.
So I'm left with 3 equals negative 7. Is that true?
No.
No.
It is false. So you would actually say this is no solution.
Oh.
Okay.
You would write the words no solution.
In that case, can every question be
No.
Yes.
Good try.
No solution.
No. Okay, so if you come out with an unreasonable answer, you would say no solution. Because 3 can never equal negative 7.
Matt, you need to learn to solve your own problems one day.
Yep.
No.
Find your X. All right. Try it's 5 through 6. We have one more example. Okay, 8th grade, keep working. I'm going to help 7th grade do their example, and then we'll do your last example, 8th grade.
We have 5 examples.
Yes, 4.
There's example 5. We have 5.
8th grade's got a heavy day. All right,
Heavy.
7th grade, let's do your next example. Shh, stop just making noise. Here we go. Ready? The table shows, this is 7th grade, 8th grade, just work quietly. The table shows the annual profits in millions of dollars of an online gaming company from 2013 to 2014. Positive numbers represent gains, meaning they made money. Negative numbers represent losses, meaning they lost money. Which statement describes the profit over the 5-year period? So we have to figure out how much money they gained or lost over the 5-year period. So how would we do that? Add all these up. So we're going to add negative 1.7 plus a negative 4.75 plus 1.7 plus 0.8 plus 3.2. Stop talking. So when you add all those up, what do you get? You may do this on a calculator. Negative 1.7 plus negative 4.75. Go team, go.
Wait, plus what?
It's right there in your book. These numbers in the chart. What'd you get? 7th grade?
3.05.
Is that what everybody got? Now you got to add up all the numbers, not just those two.
0.75.
Positive or negative? Yes, negative. So what's the negative mean?
They lost.
They lost. So which of these statements makes sense?
They lost 75.
Okay, 0.75 million is 750 million. So you do have to change the decimal to millions. So the correct answer is actually D. They lost $750,000. Think this gaming company is still in operation?
No.
That's a lot of money to lose. I mean, they did have 3 good years, but I guess it depends what their investors decide. Any questions? All right. You guys have your self-assessments. That's it. So just finish through number 13, 7th grade. That's all you have through number 13. Quick question? Okay, I'll come help in a minute. Did you have a quick question? Okay, so do you guys want me to do number 8?
Yes.
7th grade, I'm going to do number 8. That one? Negative 7/10 plus 1/5. All right, so negative 7/10 plus 1/5, right?
Yeah.
Okay, we're adding fractions. What's the first thing I need to do?
Denominator.
Get a common denominator. Can I turn either one of these denominators into the other one?
Yes.
Yeah, the 5 could be a 10, right?
Yeah.
How do I make the 5 a 10? So I rewrite negative 7/10 plus 2 times 1 is? 5 times 2 is? When you're adding fractions, the bottom number just carries across. What is negative 7 plus 2? Negative 5. Okay, now my last step, can I reduce this?
Oh yeah.
Yes.
Divide both by 5, right?
Yeah.
So this would be 1/2. Make sense?
Yeah.
If you have a question, ask it. I'm more than willing to help. Good. All right. 8th grade, we need to do your next example. Apologies for jumping around a bunch. Example 4, put this in your journals, 8th grade. Make sure everybody's there. So your first step is to write it in your journal, the equation. Example 4, quattro. Okay, so what is the first thing we want to do looking at this? Yes, Kerwin. No, we wrote it down. Close. Camila, we got to distribute. We need to distribute this 4. Okay? Oh, it just shows me the answer. 4 times 3/2 is? 6x. And then 4 times 1 is? 4. What do you notice?
They're the same.
They're the same.
Wow.
So if we subtract stuff to get to both sides, we're going to end up with what?
4.
4 equals 4, right?
Yes.
Wow.
So when you have, does 4 equal 4?
Yes.
Yes, it does. So the long story short here is any number I plug in for x is going to make this statement true, right? Because I'm going to solve it. It's always going to come out to be 4 equals 4. So then this has infinitely many solutions. Infinitely many, right here. Infinite many solutions. You've also heard it say all real numbers. Okay, so the answer to this one is infinitely many solutions. You would write those 3 words. Infinitely many solutions. Any questions on that?
No.
Okay. So far, if you come out with a number equaling not the same number, it would be no solution because you can't do that. If you come out with a number equaling itself, that's infinitely many solutions. Okay, your other option is to come out with an actual solution where x equals a number. So those are your 3 possible ways to solve these. Good. You have another example. You have 5. Don't say that. There are 6 examples.
Oh, there's 6.
It's just a long lesson. You have till Monday. You have all weekend to finish the practice. And I'll give you till Monday to turn this in as well. Yeah, I won't count it off. So that being said, let's do the next example. I know. Yeah, I'll give 8th grade. You guys can have till Monday to turn in your try-its and self-assessments. No, this is 8th grade. 7th grade, y'all are just working. Get your assignment done. Okay. 8th grade, you ready? Example 5. We're on 5. The circles on the right are identical. What is the area of each circle? So does anybody know the formula for area of a circle?
Circumference. C equals pi r
That's
squared. Yeah.
that's not area. What?
C equals pi r squared.
Oh, they don't put it on here.
Oh. Why did that?
Okay, well, to solve for x, so you can solve for the area, we can set the radius to be identical, right? Say yes.
Yes. Yes. Yes.
So this radius is x plus 2. So you see that they put that here. The diameter on this one is 4x. So how do you find the radius?
Split it in half.
Half the diameter. So that's how they got 2x.
Okay.
So if you set this one to equal this one, we can solve for x, right? So now we combine like terms. So I would subtract the x over here. So minus x, so 2 equals x. So now I can plug that in to the x to find out what the radius is of each of these circles, right?
Yes.
What is 2 plus 2?
4.
So the radius is 4. And then, yes, you had it right. The area of a circle is pi r squared. Okay, so we solved for r, which was 4. So what is 4 squared?
4 squared,
16. So you can see they left it as 16 pi. That is an appropriate answer for the area of a circle. You could also have solved it 16 times 3.14. But C would be your answer. I'll give you just a moment to write all that down. Okay, last example, 8th grade. A boat travels X miles per hour upstream on the Mississippi River. On the return trip, the boat travels 2 miles per hour faster. Why do you think that is? They're going downstream, the water. Yep. How far does the boat travel upstream? So the first thing we need to do is write what we know. We know that upstream and downstream, they're going the same distance, right? Okay, so the speed of the boat on the return trip is just a little faster, right?
Yes.
So it's the speed plus the 2 miles per hour. So you see how they have x plus 2. So now we're going to write our equation. So the distance upstream is the rate that we go upstream times how fast it took us. You don't have to write this part unless it would help you. Please write it. The distance of the return trip is the rate downstream times how fast. Oh, it went ahead and showed you. The rate upstream was x times 3 because it took us 3 hours. So the return trip times time. So we know the return trip is however long plus 2. And then how fast was it? What's in the green? 2.5 hours. So you'd multiply times 2.5. Do you see how we set that up?
Yes.
It's important you guys understand how we set that up. So now we have an equation we can solve. I heard, wait, what's up? Ask it. Somebody else is thinking.
I don't know.
So what happened is we created an equation so we can solve for x. X is how many miles per hour we went on the boat. We go faster downstream than upstream, which is why we have this x plus 2, because we know we're going 2 miles per hour faster. We're trying to find the speed that we took. So you take the distance, which we don't know the distance, x, times how long it took. Going up, it took 3 hours. So x times 3 is the first part. That equals, because we know the other coming back was the same distance, we just did it faster. The distance plus 2, and then we multiply that times how long it took us. Good. Okay, now we can solve for x. So 3 times x is just 3x. And then this one we distributed. 2.5 times x is 2.5x. 2.5 times 2 is 5. Write that down. Now we need to combine like terms. So let's move the 2.5x over to the 3x. So subtract, since it's a positive. Got something in my eyeball. What's 3 minus 2.5? 0.5. X equals 5. Now, how do I get the x by itself? Divide 0.5 away. What is 5 divided by 0.5? 10. So, bless you, the boat traveled 10 miles per hour for 3 hours upstream. And then we knew it was going 2 miles per hour faster downstream, so how many miles per hour did it go downstream?
20.
No, 2 miles faster, not 10 miles. So it went 12 miles per hour coming south, or downstream. I guess it's not necessarily south. Okay, and then the last step was to solve for how many miles we went all together. If I'm going 10 miles per hour and I went 3 hours, you do 10 times 3. I actually drove 30 miles upstream. Excellent. Questions? So that's your last example. You will have until Monday to turn this assignment in. However, I am going to give you the practice assignment tomorrow in addition. Okay? So don't dilly-dally on this. Try and work on it tonight. Try and work on it during your free time today. Okay? Let me close this. It is already recess. Let me make sure. So 8th grade, just to clear, you got to go all the way to number 19 before you stop. 8th grade.
Yes, ma'am.
Good. All right, I'm going to pause. Bye, online.